Next topic, extension of range in moving iron instruments. Moving iron instruments can be built for a range up to 50 amperes. Since in these instruments, moving parts don't carry any current like PMMC instruments, which is discussed previously. However, if you need to extend the range of moving iron instruments, a small modification is required in existing circuit as shown here. These moving iron instruments is used for current measurements, which is used as a ammeter as shown here. In this circuit, a shunt is required to use it with a ammeter to extend the range. The inductance of both the meter coil and the shunt must be considered along with their resistances. In previously PMMC instruments, the coil inductance is negligible because most of the PMMC instruments are used for DC measurements. But here, AC measurements, the inductance of both basic meter coil and shunt element is considered. As shown here, a shunt placed in parallel with the basic meter. In this, Rm is represent meter coil resistance. Basic meter coil resistance is Rm and basic meter inductance is Lm. Here Lm is nothing but a full scale deflection current of basic meter, and here ISH, the current flowing through the shunt element is ISH, and RSH, the shunt element resistance is RSH. LSH, inductance of the shunt element. Here measured current or to be measured current is I, as shown here. I equal to full scale meter current plus shunt element current, as shown here. Here measured current I equal to shunt element current ISH plus basic meter current IM, and also the voltage drop across basic meter Vm, and the voltage across shunt element VSH is equal because these two are connected in parallel. Therefore, Vm equal to VSH. Vm equal to Im into impedance of the basic meter equal to ISH into impedance of the shunt element. Here the ratio ISH by Im equal to square root of Rm square plus omega Lm whole square by square root of RSH plus omega LSH whole square. These equations can be simplified as the ratio ISH by Im equal to RSH by Rm into square root of 1 plus omega Lm by Rm whole square by 1 plus omega LSH by RSH whole square. Here the terms omega Lm by Rm is nothing but the time constant of basic meter, and also omega LSH by RSH equal to time constant of the shunt element. Here from this equation we can say that the ratio of two currents ISH by Im are depends on the term omega, means frequency. In order to make readings independent of the frequency, LSH by RSH must be equal to Lm by Rm, or the time constant of the basic meter is equal to the time constant of the shunt element. As earlier we had mentioned that the moving iron coils can be designed to carry as high as a current of 50 amperes since they are stationary. Therefore, shunts are normally not required in MI instruments. For AC applications, the extension of the range is required. Then we have to choose for CT, means current transformers are used. As shown here, to extending the range of voltmeter, a series element is connected in series with the basic meter. The series element is required to limit the voltage across the basic meter, which means high voltage V is limited to basic meter voltage Vm only, which means the full scale deflection current is flows through the basic meter, therefore the meter is safe. As shown in figure, here the Rm nothing but meter resistance, Lm is meter coil inductance, and also the measured current or full scale deflecting meter current and shunt element current. These three are equal because connected in series. And Vm is nothing but the voltage across the basic meter. Vse is nothing but the voltage across the series resistance or series element. The total resistance V is nothing but Vm plus Vsc. For operation of AC supply, the frequency is changes, hence the impedance of voltmeter circuit remain constant over a large frequency range. The current I in the above instrument coil for a given applied voltage V is given by I equal to V by impedance of the whole circuit is here. I equal to V by square root of Rm plus Rsc whole square plus omega Lm whole square. The deflection of moving iron voltmeter depends upon the current flowing through the coil. Therefore, the deflection for a given voltage will be high at low frequency and less at high frequency. This type of error can be compensated by connecting a capacitor C across series element RSC as shown in figure above. Here the idea for shunting the series resistor is to make the circuit behave like a few resistor. Therefore, the frequency changes have no effect on the readings of the basic meter instrument. Therefore, compensated instrument will have unity form factor. As shown in figure, the impedance of this whole circuit is Z equal to Rm plus J omega Lm plus the paralleling of the series resistor and compensated capacitor impedances. The impedance Z equal to Rm plus J omega Lm plus combination of parallel series resistance and compensated capacitance. Simplify this one, we have to get compensated capacitance CS equal to 0.41 Lm by RSC whole square. Like, share and subscribe this channel for more videos. Thank you.